Update on a temperature switch for the refrigerator here. That's our chest freezer converted to a refrigerator.
Alright, so this version of the temperature switch uses a solid state relay and a much simplified wiring.
Okay, tell us about the case, because this is now our universal component case.
Modular case still being developed for extreme reliability, outdoor use, waterproofing and such. So at this point, it's pretty early, but it's quite functional. Also used for the float switch. So be sure to take off the input power when dealing especially with the high voltage. So quite simple, you have two terminal blocks on both sides. One terminal block is associated with major power, other terminal block associated with the temperature sensor connection, and the power supply which provides power to this Arduino Uno microcontroller.
It's a little well worked.
So when you have the temperature sensor powered by the Arduino Uno's 5 volt regulated, and it pretty much picks up the voltage that the temperature sensor gives out. It's about it increases 10 millivolts per every Kelvin of temperature, and it was calibrated using infrared thermometer on the software side, so that the offset you put in software instead of in hardware, where you would have a variable resistor and change the resistance until you have the actual temperature equal to the sensed temperature.
Tell us more about the calibration with infrared sensor.
Oh, for the infrared thermometer, you essentially take a reading, you point the laser at, you point the sensor at, say, the sensor, and you also connect the sensor setup with the microcontroller to the computer, and the code has it such that you print out the temperature that it's sensing into the serial monitor of the Arduino integrated development environment, such that you can compare the temperature that you see that it puts out and the temperature you see with the infrared thermometer. So this assumes that the infrared thermometer is correct and just calibrates it such that the reading you get from the infrared thermometer is equal to the reading you get on the serial monitor. And you do this by saying, in the code for the microcontroller, for example, the offset increases to plus 5.5 Kelvin, or 5.5 degrees Celsius. Yeah.
All right.
So right now, it's as you can see, the LED is on, and that means the relay is activated. If we were testing this while it was not activated, it'd be a lot easier to show how if you heat the sensor up, then it actually deactivates. In fact, because we have that finished, we can just put back this case, and hopefully the bottom heats up quite a bit, so it might need the heat sink. So that's another point I want to say.
Which part heats up?
The solid state relay heats up a bit, so it's nice to have a heatsink right below it. Other than that, let's repower this. And what would happen is, if it wasn't already on and if it was cooled down, then when you say, just as a show run, if you heat this up, then that would activate. Okay, it's cool enough. Oh, but it turns on again. Intermittence, but it's okay.
Okay, so that's the modular case.
Yep.
Now the interesting thing for the audience here is that same case was what you showed for the float switch.
That's correct. Yeah.
So this is our universal controller box. Now, are we going to use a similar one for the CEB? So we're going to.
We can.
Okay, so change that form. So we'll make this. We'll have to make this waterproof next time.
That's correct. Exactly.
Okay, excellent.